Hello, my name's Colin, and I'll be your guide for today. We're going to be learning about inverse functions. Consider the doubling function, f of x equals 2x, whose rule is to simply double any input. For instance, when the input is 3, the output is 6. The inverse function of f simply undoes the original function by directing outputs back to their respective inputs. So for the function above, throwing 6 into its inverse function will result in 3 being recovered. Hence the inverse function of the doubling function is the halving function, since the inverse operation of doubling is halving. Now, despite the curious notation, keep in mind that f inverse is not the same as f of x to the power of -1, which is an entirely different concept. It's important to note that just as how halving cancels out doubling, doubling will of course also cancel out halving. Therefore, it doesn't matter if you double a number and then halve it, or if you halve first and then double, you'll always end up with the same number. Hence, we say that f and f inverse are mutually inverse functions, and that they cancel each other out in any order. Algebraically, this so-called cancellation property of inverses can be stated in the following way. Let's examine these two identities in more detail by applying them to our doubling and halving functions. For any input x, suppose we do the doubling first and then the halving. That is, the function f doubles the x to become 2x, which f inverse then halves, thereby recovering the original input x. Diagrammatically, this is what happened. Now, suppose for any input x, we do the halving first and then the doubling. That is, f inverse halves the x to become a half x, which f then doubles, thereby recovering the original input x. Diagrammatically, this is what happened. You should note that the following identities from the 2-unit HSC Mathematics course, which effectively states that the operations of logging and exponentiating cancel each other out, arise precisely because the natural logarithm and exponential functions are mutually inverse functions. So far, we've considered two pairs of mutually inverse functions. However, it turns out that not all functions have inverses. In the next module, we will investigate the conditions under which a given function will be invertible. Moreover, we will also learn how to find the formula of an inverse function, if it exists, along with how to sketch their graphs. And here's a summary of what we've learned in this module.